All right, so we are, excuse me, we are continuing the lecture from the last class. In the last class, you may remember we tried to understand how to identify the object codes of an instruction. We don't understand the instruction yet, but I believe that after practicing the quiz questions, quiz 1, we now understand how to identify the object code of any instruction. Doesn't matter how they look like. And doesn't matter how they work. Now, today we'll try the next step, which is to understand the object code of an instruction. Now, what do I mean by object code first? See the code you will be writing, the instruction you will be writing in the assembler, those are very close to the machine. So it's just like, one step to the machine. So we just need one step translation to convert the whole thing into machine code. Now for each instruction you will get a machine code, right? Remember, the machine code means a bunch of binary numbers. But when we will be writing here, we'll be writing everything in hex. This is just a different number system because we prefer writing in hex, though machine understand it in binary, because binary numbers are long, right? So instead of writing in binary, if you write it in hex, it looks small and you can see it clearly. So that's why we will be writing the object code in hex numbers. But remember, in the computer, at the end of the day, everything is binary. Okay. So we are talking about, for an example, here we have an instruction. Let's say you see here in the screen, the instruction is SUBB35. Let's say. Now the question is, after the translation, remember the translation means translation into machine code. Okay. What will be the machine code for this instruction? Okay. Remember, for each and every instruction, there will be a machine code which machine, meaning microprocessor, directly understands. Okay. Now, what will be the machine code for this? So, we want to understand for each and every instruction what will be the machine code. Now, to understand the machine code, I think we have seen some of this instruction in last class, but we wanted to identify their addressing mode, not the machine code. Now, when you see such an instruction, the first step would be to know what is their addressing, what is the addressing mode of that instruction. Can anyone here tell me what is the addressing mode? What is the set of instruction? Make sure we have the set of instruction every time we discuss, because we need to see that whether there is exception for direct mode. Even the instruction look like direct, it may not be direct because the instruction doesn't have direct mode, so be careful about that. So just to make sure, what is the addressing mode of this instruction? Alright, so before we move forward, let's look at that, look at the set of instruction here. We all have this, right? Is anyone here who do not have the set of instruction? Okay. So make sure you always have this set of instruction anytime you are discussing in the class. So again, the instruction was SUBB, right? Now what is the addressing mode of that instruction? What is the addressing mode? Direct. Everyone has the same agreement. It's direct. So there is no hash, so this is not immediate, and the operand is 1 byte, right? So that's direct. So the instruction is SUBB, and you know that all the instructions here, those are alphabetically ordered. So based on that, let's find the SUBB here. Let's see what we have for SUBB. Now when you go to SUBB, this is alphabetically ordered. This is your instruction SUBB, right? Do you see it? Do you see SUBB here? Now, again, we don't understand the instruction yet, but since we know that this is SUBB, but the addressing mode is direct. So let's look at here. You see here, these are all the available instruction addressing mode for this instruction. But for the direct, so this is the direct, right? DIR, right? For the direct, this is going to be the opcode. Now remember, every instruction for different addressing mode, when it being translated, it becomes a different object code based on the addressing mode. And that's what exactly you see here. For an example, if SUBB is in immediate mode, then the object code is going to be C0. I'm sorry, not the object code, opcode. If SUBB is direct, the opcode is going to be D0. Extended F0. You see what I'm saying? So, based on the addressing mode, the opcode is going to be, the object code, you have two different parts. One is the opcode and another one is going to be the operand. So if I go back to that slide, let's check what we are writing. So now we know that since the addressing mode is direct, the opcode is going to be D0. Let's go back. Okay, here. So now what we did, so this is going to be the green one, is going to be your answer. So this is the object code of the instruction. So in the object code, what do you have? In the first part, you will have the opcode, which is directly coming from the set of instructions. We saw it, right? Which is directly coming from the set of instructions. We know it from there that this is going to be D0. Now, how did I get 23 there? That might be an interesting question. Now, first of all, before we go there, look at the operand we have here in the instruction. What is the operand you have in the instruction? Do you see the operand in the instruction? 35, right? Do you agree that is the operand? Remember, in the instruction we have two parts, right? The first part is the opcode. Second part is the operand, right? Let me remind you something. Let's go back to the original, just to remember. Remember this slide at the beginning, very beginning, we just tried to make sure that what do we have in the instruction? We have the first part is the opcode, right? Now, after the decoding, this opcode becomes a number. And after decoding, the second part operand is also becomes a number. Now remember, all we are trying at this point is to write this object code from the instruction. So we will be given the instruction, and based on the instruction we have to find what will be the object code of the instruction. Now to do that, what we are doing is we are trying to find the addressing mode of the instruction first. Once we know the object code, the addressing mode, for an example, the sub BB35, we know that the addressing mode is direct. So we check the set of instruction and we know that for the direct SUBB, the opcode is going to be D0. So we wrote the opcode D0. Now how, and here the operand is 35, right? Now what is the number system for the operand? Is this hex, decimal? It's not binary for sure, right? Because this is 35. It cannot be binary. We are sure that is decimal, everyone? That is decimal because remember, last class we said that if that is hex, it should be preceded by a $sign, right? 35 should be preceded by a $sign. Since there is no $sign, that is binary, that is decimal. Now, when you write anything in object code, you must have to write it in hex. So now that's why we converted 35 into hex. And we got 23. So basically, 23 is the hex of 35. So remember, when you are writing the object code, in the first part, you'll be writing the opcode. In the second part, you'll be just directly copying the operand. But remember, the operand has to be in hex. since the operand here was not in hex, it was in decimal, we converted 35 into hex, which is 23. And that's it. That's what you are going to write. So, can anyone tell me D023, how many bytes you have there? Remember, when you are storing the bit into memory locations, you need bytes, right? How many bytes are going to be there? There must be 8 byte. I'm sorry, 8 bit, right? For D0, and another 8 bit for 23. So they are going. So the instruction will take 2 byte here. Remember, as I mentioned in the last class, that 2 hex digit means 1 byte. Do you remember that? 2 hex digits. See, all these are in hex, right? D023. All these are in hex. So D0 will take 1 byte, and 23 will take another byte. So there will be 2 bytes for this instruction, because when you are writing the instruction, when all the instructions are being converted, they also take memory locations, right? Because you have to store it somewhere, and that's how they take 2 bytes. This one, I'm talking about only this one. So you have to check time, because most of the instructions will be taking either from 1 byte to 3 bytes. So it may be taking 1 byte or 2 byte or 3 byte. We'll see that variation. Now, next example. What is the addressing mode for this one? What is the addressing mode? Inherent. Can you find the object code for that? Look at the set of instruction. 1B, that's it. Because the inherent, we don't have operand, so just one. So how many bytes you have here for the object code? 1 byte. That's just 1 byte. Let's look at another example. STD A2B. What is the object code? Remember, to find the object code, you first have to know what will be the addressing mode. Okay, anyone help me? What is the addressing mode for this one, for this instruction? Yeah, for STD, it's not STD only, because there is a data part as well, right? What is the addressing mode? Remember, we discussed the addressing mode last class, right? And we had the quiz questions there. What is the addressing mode? Oops. Addressing mode. Nobody knows what is the addressing mode of this instruction? It must be extended, right? Because first of all, there is no pound sign with the operand, so this is not immediate. And the data is more than a byte, right? So that must be extended. Now let's go back to the set of instruction and find STD. Okay, now this is your STD here. And as we know that this is extended, so the opcode is going to be FD, right? So let's go back to the slide and see. Okay, so this is going to be FD, but look at the data part. Now this is the first time you see the data is in 2 byte, right? Now how do you write A to B in 2 byte? Because you have to pair, right? You have to write hex digit in pair, because each pair means 1 byte. You see what I'm saying? So that's why we are writing 0A2B. You see what I'm saying? Because you have to feel the first, because you just have 3 digits in the hex. So you fill the first digit by 0, because you need 4 digits. You cannot make it 2, right? Because there are already 3. And what we also have a space between the bytes, just to make sure, just to show that, okay, there are 3 bytes. First byte, space. Second byte, space. third byte. You see what I'm saying? But you know that first byte is coming from the opcode, and the next 2 bytes are coming from the operand, because this time the operand is more than a byte. And this will always happen in case of extended, because in case of extended, your data, your operand, the operand is going to be 2 bytes. Is always, right? It's always going to be 2 bytes, so that's why your operand will look like this. Any question here? Let's check the next to another one. First, what is the addressing mode? That will be the first question. Once you know the addressing mode, we'll go back to the set of instruction, we'll check that opcode, and then what is the addressing mode? Direct extended. What is that? It's extended because, first of all, look at the operand. It's more than 255, right? Remember we discussed this one in last class. If you this is in decimal, right? The operand is in decimal. If the decimal number is larger than 255, you cannot write it in 1 byte. It's going to be extended. What is the opcode then for the STX extended? Everyone got FF? Did you find the opcode? Now, if it is FF, what will be the operand then? But remember, as I mentioned, the operand here is in decimal, right? You always want to write operand in hex. So you have to convert 256 into hex, okay, which is 100. How do you convert it? Digital circuit class. Okay, so and also I can show you some example here, which will make your life a little bit easier, because you can also use a calculator here. If I use the calculator, go to the programmer's mode. Once you change the programmer mode, you can do it directly here. Look at this. At this point, the number system is decimal. So let's write 256 here and click into hex. It changes the number system to 100. So that means 256 means 100 in hex. Now once we know that, let's write the object code. So we know that the object code is opcode for STX is FF, because this is extended, right? And the data is 100, but you want to write it in 4 digit, right? Because it's 2 byte. Data is in 2 byte for sure. This is extended mode, right? So how do you write in 4 byte? You just write 01 space 00. That's how the object code is going to be 3 bytes. Any question here? Yes. It depends, because it might be already 4. That's what I'm saying. Now you converted the extended, it becomes 100, right? So I'm saying there are only 3 digits, so that's why we fill the first position by 0. It might be the case that you have already 4 digits. You see what I'm saying? So in that case, you don't have to fill by 0. Let's say your operand is ABCD. Just keep it ABCD, because you already have like 4, because you have to show the filler, right? Because the remaining part will be filled by zeros. Let's try this one. What is going to be the opcode? Check the set of instruction. ADDA. What is the addressing mode here? Addressing mode. This must be immediate, right? Because there is a hash, pound sign. So what will be the opcode? Let's check this one. The opcode is 8B, and look at the data. Operand here. What is the number system for that? Is in binary? Oh, it's not in binary for sure. Is in decimal or in hex? 3512. That is in decimal, right? Because there is no $sign. So that is in decimal. Now we convert it 3512 into hex. we got DB8, and then we fill the left position by 0, so that's how it becomes 0DB8. Don't forget that you always want to write it in hex. So 3512, since it is in decimal, we convert it into hex, which is DB8, but we just fill the leftmost digit by 0. How about this one, NEG29? What is the addressing mode here? What is the addressing mode for NEG29? This must be extended because this looks direct, but it doesn't have direct mode, right? The NEG does not have any direct mode, so by default this becomes extended. Now when this is extended, what is the opcode? NEG, what is the opcode for NEG? 70 is the opcode. But look at this, look at how we are writing the operand. Because remember, since this is extended, your operand must be in 2 byte, right? Look at how we write the 2 byte. Because once we convert the 29, we got only 1D, right? But we have to write it in 2 bytes. That's why we wrote 001D. Do you see that? Because this is extended. Be careful about that. In case of extended, you always want to write the data in 2 byte. 29 converted into hex, which is 1D. So that's why we put 2 zeros in front of those to make it 2 byte. Now it becomes 70, and then operand becomes 001D. Any question here? In case of extended, remember the operand is always going to be 2 byte. Doesn't matter how it is, we will make it 2 byte. We will have to make it 2 byte. So now we are ready for quiz 2. So let's go back to the pause, quiz section, and let's start the quiz 2. Our machine will not be able to handle that. I'm talking about the microprocessor because you remember the microprocessor we were discussing other day. You had 2 bytes for the addressing, right? And you had 1 byte for data. But there are some exceptions of data because I'll show you that when the data is a little bit different than, but you know, we cannot handle more than 2 bytes for sure. So now we are ready for quiz 2. In the quiz 2, you have to write the object code, okay? You saw how we write, right? So these are examples. You have the PowerPoint, and also the lecture will be there in the Tegrity with the voice. Any question? All right, so let's stop this part here. Remember, this lecture will continue, okay, because this is a big lecture. We'll stop at different points once we're ready for different quizzes, okay.